Welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Umwaka. I am your instructor. Today, I will be showing you how to use Protastructure software to perform a full structural design of a concrete building. So by the end of this lesson, you will be able to perform a full structural design of a concrete building using the software Protastructure software. Okay, so let's begin right now for the full design of this concrete building. Okay. Hello, welcome to Ekidel, where we train future civil and structural engineer. Today, I will be showing you a full structural design using Protastructure software. So by the end of this lesson, you will be able to perform a full structural design for any concrete building using the software Protastructure. Okay, so right now, once you're done with your general arrangement drawing, as you have seen before, and then the next thing to do right now is to open the software, which is the Protastructure software. And then once you open the software, the next thing to do is to import your general arrangement drawing building plan. So right now, I'll just go to this place called external reference drawing. So I'll click on this place once I open my Protastructure, and then I put on this place called add. Meanwhile, I am using the version of Prota 2021, so I'll just go and locate my DSF file, which is already here, and then I'll click on this and then click on open. And then I'll now click on this place called activate 3D and then use color. And then I will now go here and then click on this place, say import, and then just click on import members, where it will now import all the grid line as axis and all the column as a column member. Then once I'm done with that, I'll now go here and click on OK. So we close, and then I'll go here and click on OK. Now automatically right now you can see all our building plan, and also the axis and also the column, as you can see it here. And also by this side, I intentionally introduced this here so that you can be seeing the kind of building that we want to perform the full structural design. So by the end of this lesson, you'll be seeing this drawing here performed fully for the structural design here. So right now, I will now go to this place right now. So you can see that all our columns are already in place. As you can see, the columns here are already in place. So right now, we will now begin to insert our beams. So to insert your beams right now, but the first, I'll first of all go and remove all the grids which are unnecessary. Like this one right now is not important for me. So I'll just delete that right now and remove some grids which are not that okay for me. Okay, for now, I think all that grids now are just okay. So I will now go here right now and click on this place, modeling, to now start begin to insert my beams. So I'll click on this place, beam icon, and then impute my beam parameters, which is, I'll just move this down here and then input my beam parameters. I want to use a beam width of 225 millimeter, and then I want to use the depth of beam of 450 millimeter. And then once I'm done that right now, I will now go here and then click at this place. But before I click here, I'll just assign a hinge end to it, and then click at this place and then click on this point right now. Now this place is a 150 wall. As you can see that this is like a bungalow having a pent floor. So because of that right now, they they used 150 millimeter wall for all their for all their block wall sizes. As you can see that all the column size width is already 150, as you can see there. So with that right now, I will now go and reduce my I will now go and reduce my width of beam to 150, and then click on what update here. Now on this update right now, I will now begin to click on other places. As you can see what I'm doing right now, you can now see that all the beams have now fit into the size of the wall. So I'll go ahead again and click at this very point here. Since I have a column here, it will try to terminate there. So I'll just click here right now, and then let me just remove this free end. After I will show you that free end, and I'll click on this place again, and then I'll just follow up the lines of the columns and where I want to insert my beam, since we have already done all the paneling before this time, which was the part 1 of this video. So if you missed the part 1 of this video, I would say you should just check on the link down below and download the part 1 of this video, and I'll click on this place again to continue, and then I'll click on the escape key and then click on this place to form this. Okay, and then I will now go here and click here and then click at this place right now and say no. This is trying to form a cantilever end here, so I'll just escape and click at this place to remove it as a cantilever end. Click at this place, sorry, click here, click this beam first to remove that point as cantilever end, and then change the this thing to supported. Okay, so right now I will now go again and then click at this concrete beam and check if now they change back the parameter to 150 by 450, which I want to use 450, and then I'll still go ahead right now and then go here right now and then continue with my modeling, which I want to put from here to this point beams. And so on this area where we have our bungalow, where we have the just the first level, you can see that we only have one level here and the roof, but this place we have a slab decking on this other place. So this is like a penthouse where all this place is now a bungalow. Okay, so right now we will now go ahead again and then begin to insert our slabs right now. So right now, I will now go to this place again and click on concrete slab and choose my slab thickness. My slab depth is 150. So I'll just go here right now and choose my slab depth and then go over to this place, the load, and then choose my dead load to be 1.5, and my imposed load, I will choose my imposed load to be 1.5 also, or I'll just right click on this point right now and choose my imposed load there, which is for the most thick building. I'll now use 1.5, and then I will now go and then click this roof load. I'll just use 0.5 because okay, 0.5, yes, and I'll leave all that values here because we don't have snow in this country. But if you're a country that has snow, then you have to put a factor of snow load. In my next videos, I will show you how to input all these values, the snow load and the rain load. Okay, so right now I'll now begin to input my slabs right now on these places which I have slabs, and then click at this place again. I have slab here, and then on this place right now there is how this slab is here, because this is like an open well staircase. So from this place, just like this, has a slab. So right now I will now go and click at this place and click on beam, and then go and click from here and insert my beam all the way down here so that it can be able to restrain the slab and get that void here. I will now go back to this place right now, click on my slab and right click and say properties, and take that slab properties and then come here and just okay, go back here right now, click here and change the beam properties to what we have it as 150, 150, and update. Okay, and then I will now go here and click on slab and then input my slab. I'll just right click on one of the slab here to take the slab property which I've already set before, and then click at this place. It's trying to insert slab. Okay, click here right now. It's trying. Okay, so right now click on this place. So right now we now have our slab here. Why here becomes the staircase area, and then this area becomes the void also. So right now we have done all this right now. So we will now go and then begin to insert our hinge end condition. So by doing this right now, since we have already done this, I will now have to go and offset this just now. So I'll click on this place because there is a beam here. We didn't offset that grid line. So I'll click on this place right now, click on this right now, right click and then say um, offset. But before then, I'm meant to measure this distance, or I'll click it at this point first, then I will now have to now move it because I already know what this distance is, which is 150. So I'll now move this grid right now to this very point, which is now move it by shift F2 75, which is the half of the wall, and then click on enter. Okay, so we now have this at this very point here again. So I will now go here and do the same thing at this very point. Click at one of these axis and then say offset and offset it to this very end. And at that point, I will now move back this grid to by 75. Shift F2. Since I'm going inward, I'll say minus 75 and I'll say enter. And then I will now go again and then go and click at my beam. Check if they have all the properties needed. No, this property should be 150. The width and the depth should be 450. Okay, so if you have any issue with Protastructure and you want us to rectify, I would say you can always reach us on our WhatsApp platform and we will take you down through. Okay, so there's a mistake here, so just delete that right now and then try to check back this. Okay, there's a mistake here, so delete that and then take back this being prop. Remove this also and take back this beam property just now. Take this beam property and click at this point and then go all the way down here and click at this very point here. Okay, there is still that mistake. I'll show you how to rectify that and click here first and then I'll just go here, click on this place, remove this and then go here again and remove this and then click on this very one right now. Okay, that's okay because this column already has two areas. Then I will now go here and then click on this slab, right click and take the properties and insert a slab all the way. Okay, we have to rectify this first. Okay, so right now we will now click on this beam right now just to rectify that issue which I told before and then click at this place properties and then click on this very place. You can see that this grid line where this beam stops is at grid line 820, but we are meant to extend this down to this very point. So click at this place right now and click on the next grid line which you want to extend it to and then click on update and it will move. And then we'll go here again and this is on grid line 821 and then we'll click at this very end here and then click on the grid line which you want to move to 25 and then click on update it and it will move. Okay, so right now if we now go ahead and now insert our slab right now, our slab will be able to insert directly at this very point as you can see it just now. Okay, so right now we now go here and click on this. So right now at this very point right now I can now go here and back to this place and external reference drawing and take off my color. I don't want to use that color again so that it will not show fully as you can see it right now. So we have done this right now and then we will now begin to now show you a hinge end. It is always good to apply hinge ends to all the end of beams. So right now I'll go here right now, click at this place. This beam already have a hinge end but it should be just at this very end here. So I click here and say end condition and end condition should be at this very point I. Now if you want to know about end condition, I would say that you should check on the most of our other videos and where we explain more on end conditions, and I'll also drop the link down below this video description. And if at all maybe during the time of the upload of this video and I didn't put it, hearing this right now, I would say just remind me back using the comment section and then just um, we will just add the link to that. Okay, so this beam also should have a hinge end at the very top here. Now if you want to know more about hinge end, I would say that um you should check our chat us up on WhatsApp platform where we can train you especially on the hinge end area. So this will be hinge A at J. Okay, at J, and then this one will not carry any hinge because it doesn't have any end condition, so we'll just take off the hinge and say hinge no hinge. Okay, and then now it is very important to use this hinge because if you don't use this hinge, the cost of the construction of the building will be very expensive. So it will be it will not be very economical. So that's why I always use hinge for my buildings. Okay, so right now I will now go to this one doesn't have a hinge. Okay, so here right now since this is a beam end condition, here will have a hinge because there's an end condition on this beam. So I'll go here right now and right click on this. Now this looks very boring to you, but if you are designing, like I told you before, we always design here for a real life project. So we are taking all this time because this is a real life project and it is for our clients. So and our mission is to save money for our clients while we also consider for the stability. So you can see that there will be a hinge right now in this place. So that's why you can see that we are taking much time doing all this because we are not just we because we didn't just pick up a plan and start making a video. We are using a real life project so that you can see how to design a real life project. Okay, so we do this also and say J, and why this now, since this is a simply supported beam, so this will be both end hinge. So go here and apply both ends hinged. Okay, like I said before, if you want to know about hinge or this hinging, I would say you can use our mentorship program and we will train you specially on building design and also structural designs. Okay, and click on this also right now and do the same thing here. Now most people does not carry out this hinging process, but I would say that if you do this, you will see that the cost of your building will be very, very economical. And if you're trying to bid for a contract with a fellow engineer and you did this and you apply this hinge to your end conditions of beams, you will see that the cost of your own um, that the cost of your own building or the bill for your own bill will be very, very minimal compared to someone who didn't apply these hinge end conditions. Okay, so right now I will now go here because what happens is that if you don't apply these hinge end conditions, this software takes every end of beam as a fixed end. And you know what happens to a fixed end? Fixed end tends um to to like provide much top reinforcement, even if where that place is not meant to be provided, but because it is a fixed end, it will tend to give you much higher top reinforcement. But normally, as we all know as we all know, even in theory, that the very moment value at every end is always zero. So because of that, right now we are trying to free this very all the end of beams not to have moments because that is how it is meant to be. So that's why we are applying all these hinge end. I've already started giving you all everything that we teach on mentorship program. Okay, so right now we do the same thing here, both ends supported. Okay, both ends. Okay, so right now again we go here and on this beam we just say left end, which is the down part, which is the I end hinge, because this other side is at continuity, so don't do that right now. So this place also we do the same thing here. Now you can see how we are taking much time. The reason we are taking all our time doing all this is because this is a real life project, and here in Ekidel all our buildings are designed using um, real life buildings and real life examples, which in the next recent months I will be showing you a clip of videos and pictures of of all the buildings that we have designed, which are already on the construction stage. Okay, so right now we do the same thing here, and then we have done all the hinge ends. You can see right now that all our beam are all having hinge ends. Okay, so right now with this right now, since we have done this right now, we will now go here. We will still leave this image here so that it can still be visible, but we will now go and then insert story. So I'll go and save so that in case there is a shutdown of this software, I'm not going to miss all everything I've done. So you always have to save once you have done a major changes to your model or your design. You have that culture of saving, because most times Protastructure tends to shut down maybe if you did any kind of wrong connection or modeling. It will just shut down, and then if you didn't save that particular changes that all that you have made, you will tend to lose it because most times it does not back up. Okay, so right now we will just wait for this right now to now save. Okay, now if you find this video very, very interesting or very, very good, I would say you should click on the subscribe button. If you're a new subscriber, click on the subscribe button, and if you are an old subscriber, I would say you should click on the like button and also share this video so that your friends and colleagues and also benefit. Okay, so right now we are done saving right now. As you can see right now, we are done saving. So right now we will now have to now go and insert story, because right now all what we have just created right now, we have created this slab here, which is this very slab here, and now we will have to now create this other story right now, which we will have to insert story to this building, to this model here right now. And then from inserting story right now, we will also can see that this cantilever here, which we have already provided for here. So right now we will now move on to what we have for today, which is right now to now begin to insert this story, and then also change our depth of roof beam that is here. So right now we will now have to now go and insert story. So go back to modeling right now. As you can see it here right now, on this modeling right now, we have done column and also inserted beam and slab. So to now insert story right now, we go back to building set out, just like name set out, then we'll go to this place called stories. As you can see it here, on these stories right now, you can choose to navigate to other stories, but we will now go here right now and click on insert stories. Okay, so right now we'll just put, since this is just a one-story building, as you can see it here, just a one-story building having just a bungalow having a penthouse. So we'll just go here and put 2. And on this place right now, we'll now click on this place called OK, and then we say yes. Now on this right now, we will now go back here and then click on story 1, as you can see it here on STO1, which is story 1, and then go back to this place and click at this place story, and then say generate story, and click on this place generate story. You must not be on this story that you have created to generate story, else it not generate. So you have to go to the previous story to be able to copy what you have on that story to the next story. So right now we want to copy the beam and the columns onto the first floor story. So click on the source story, which is story 1, which we have already done all the models, and then we click on story 2. By doing this right now, we are copying all the beams and columns to this very one, but we don't want to copy slabs, so we'll just uncheck slabs, because at this place right now we are trying to create a roof beam. So we'll now go here right now and click on this place called OK, and then we will now go move on right now. Once this is done completed, we now go here and click on word close, and then you can now see we now have story 2 already appeared, and we have story 1 also. As you can see, our story 1 here still having this. Now we go back to story 2 right now, which is story 2 here. We go back to story 2 right now, and then begin to decrease our depth of beam, because right now on this place there is no slab. So we go here and then begin to decrease our depth of beam to 300. So we will just go right here on this place, on this structure tree right now, and click on this place and say beam table. On this story 2 right now, which is the beam table, a dialog box will appear. So we'll now click on this place, which is the H here, and you select all the depth of the beam found on this story 2, and then we'll click on this place called column wise edit, and then go here and then input your or choose your new depth. So our new depth is 300, so just go here and choose 300. You can also type the value here which you want, 300, and then we'll just go and say OK, and then wait for it to change automatically. Now it has finished changing, so just go here and click on close, and then you can now see that all our size of beams for this story have changed all to 300. Why still on story 1 we are still having 450, which is the minimum depth of this thing that you're meant to use. Now during our design, if perform our design, and if this depth is not sufficient, we will change it. So this place that are not carrying slab, because as you can see the building here, only this place is carrying slab, while here is just like a bungalow. So we will have to reduce the depth of beam, because on this place, because on this place it is a roof beam, but on this other side it is a floor beam. So we will have to reduce all the beams that are not carrying slabs, which are around this area. So just hold our control key by now doing multi-select by using our control key and selecting all the beams together, so that we can change the depth at once instead of changing one after the other, which will take longer time. So just go here and just be clicking by holding control key, and now select all the beams that we want to change, which we are almost done right now. And then once we are done selecting that, as you can see that which is the perimeter, we'll now right click here and then say properties, automatically it will show you this dialog box, and then click on this place and click again on this place, and then choose our depth of beam there to be 300 and say okay, and then we now go here and then click at this place. Once it is done changing, we now click on close. So let's wait for it to change and then click on close, and automatically it has changed all the depth to 300. As you can see it very here, where here is 300, and once it enters the place where the half slab, you can see that it is 450. Okay, so right now you can now see what we have done right now. Next thing to do right now is to now edit the height of the stories. So the height of the story simply means from this point to this point. You can see that this is a DPC which have a step. At least you are going to climb 1, 2, 3, 4 steps before you can enter the building. So with this right now, the DPC of this place is 600. So right now we'll just go and apply that depth of 600 for the DPC, and also apply the height of this ground floor, which is 3150 millimeter, and here is just 3 meter. So go here right now and click on this place and click on edit story, and then we will now go and click on this place. This first story button level simply means DPC, so put their DPC 600 as we have seen there. Now on this place foundation depth, I would say you should leave it as default, because no one can eventually determine the foundation depth during design. It is when you have gone to site that you will now see how the soil is, like how the nature of the soil is. Then from there you can now know your foundation depth. Okay, so right now we will now go here and then impute our height of story 1, which is 3150, and the height of story 2 remains as 3000, so it's just 3000 there. And then we will now go here and click on OK and say yes. Automatically say yes, and then we have now edited all what we have here, and also the same thing we have here. So we will now move on right now to the very stage that we have right now. Now, if you look at this cantilever here right now, you can see that this cantilever does not touch directly at the column here, but if you look at this, it's going to touch at the column. So this slab right now, we are going to remove it because it's not directly touch at the column. The distance of this cantilever from here to here, or the distance or the difference from here to here, is just 300. So we will just go here and remove this slab right now, and then click at this place to offset this grid line backward by 300. So we will just go here right now by clicking on this offset. Going backward, we just hold Shift F2 and type our value of 300 and say enter. So with that right now, this is now the point of our cantilever slab to stop. So we will just go here right now, go to modeling and click on slab, and then go here to insert your cantilever slab right now. You just go here and change the type of this place to type 12. Type 12 simply means cantilever, and we'll put our depth of slab of cantilever slab as 150, and then go to this place right now, loads, and then choose the same thing 1.5 as our dead load, and then impose load. Right click and choose the most load, and then go here and choose 0.5. Okay, and then we will now go here and then say cantilever, where we will now have to now input our cantilever length. Cantilever length, which is on this place, is from here to here. This from here to here is 900, so this should be 600. So put in 600 first, and if it's not within this point, they will make it to reach this point. So right now we will now go here and put parapet load. We say 9.81. Okay, and then that's all we have to do here, and we will now go here by clicking on from this point right now, to this very point right now, and then click on this. So seeing this right now, you can see that the cantilever slab edge does not hit at the very point, so we will just have to make it up to it there. So I believe that should be let us dimension that to check the dimension of this distance. So just go here right now, click at this place and say measure. So click from this very point, from this face to this very face here, which gives us 713. So 713 now becomes that cantilever end. So just go here, click on this place properties, and then go to this place cantilever and say 713, and then say update, and let's see it is now flush at that very point. Yes, okay, that's so right now. It's not flush right now. So we will now do this how it is at this very place. You can see it here. So right now we have done all this right now. It's now time to now go and look at the 3D to see what we have just done right now. So go to this place right now, which is called view right now. I click on this place and say 3D physical model. So click on that right now to now go and see what we have just achieved just now. So let us hold on for the 3D model to like show up right now. Okay, so you can now see what we have done right now. Okay, so you can now see what we have just done right now. So right now it's not time. Let me hide the grid lines so that you can see it very visible. So I'll just hide my grid line right here to hide my grid lines. And then, so since I have done with the model right now, next thing to do right now is to now remove this, is to now take off all these building plans here, this picture icon here that came with our model, because the whole idea is just to be able to guide you on kind of thing that we have. So right now we are not yet done, because you can see that this place does not go directly up to the roof, but from what we have here you can see that it goes directly to the roof here. So we have to now remove we have to now remove all these very points at this very edge here. So take off this very edge here, and also take off this one right now, because this one does not follow us down to the roof. It stops directly at this very place. So just take off all these beams right now and the columns that are coming on this very area. So we'll take off this. Let me just hold my control key and select them automatically, and then do the same here, and then here does not go. So click on this, and the columns also are going down. So just take them off, take this off, take this off, and take this off also, and then we will now click on delete. So with this right now you can now see how the views is coming out as we have on this, you can see that right now. So we'll just go here and then show you the view right now. So this is what the view that we have right now. You can see that. So I do not like this color. I don't like this color. You can also see our cantilever slab, just can see there. So I do not like using this very color for anything I want to do. So what I'll do right now, then this place also does not have a beam crossing over it. So I'll just remove that beam right now, take off the beam just now. Okay, and then this place also doesn't have this beam crossing over it. So I'll just take off this beam also, because it's just a cantilever slab that is just showing there. So also on this place now, I'll remove this beam now. So since I've removed all the beam right now, that means invariably this column is now a slender column. So I have to remove this right now, and remove this also, then now apply this column to be a slender column. But before I do that right now, I'll just have to turn off my this external reference drawing lines, that you can see everything I'm doing clearly. So I'll just say okay. So you can now see that we have a clear view, as you can see there right now. So right now I will now show you how to apply a slender column. So on this right now, I click on this place, right click, and then say properties, and I will now go here and click at this place called on this place right now, length of story. Since I want it to go down, I'll now go here and put 2 instead of 1. I'll just put 2, and I'll say update. Once I click on update right now, automatically to go down to the foundation level. So I'll click on this place update, and to just go down right now, you can see there. So right now again, I'll go on this place again and click at this very one again. So click at this very one again right now, and click and say properties, and then go here and click and type 2, and I'll say updates, and to go down again, and can see that. And then so we now have this very what we have just done. Just I can see what we have achieved just now. I can see that right now. So this now becomes our staircase, as you already know. So you can see what we have just achieved just now. So which if I you can see the very void here as our staircase void. You can see that. Now if I go back again to now and turn on my external reference drawing, you can see what, let me just show you what we have achieved just now. So you can, if you see this very shape here right now, that this place, this level stops at this very level, and you can see it also here that this is the level that stops there. You can see there, you can see that this level stops here, why this place goes up, as you can see, and we have a cantilever slab, and this column is a standalone column which is called a slender column. From the top down to the foundation, there is no it doesn't have a connection between the beam and the column itself. So that is what we have also achieved here. As you can see it here, there is no connection between the column. Let me just turn it off again to show you clearer again. So if you look at this one right now, this column is called a short column because there is a connection between this and this. You can see that there's a connection between these two column, this column and the beam, but on this one right now it has no connection. It's just from top to down, so it is called a slender column, and it is about over 6 meters high, as you can see there. So right now we have done this right now. So I like to change my color, so I can choose back to activate back the that grid lines, and then go all the way down here and then click at story 00, so that grid line will have to go downward. Okay, I can also choose to off it up just to show a clearer view. So right now I like to change my colors because I don't like using this very color, Prota color, because it looks some way. Let me go to 3D view again. I don't like using this very color of this 3D view because of this default Prota color, because it doesn't look nice to my own taste. So I like to change my color. So I'll show you how to change color right now. Which if you don't like this color, you just go here and click on this place, layer and color settings. So once the dialog box appears right now, you can change the colors that you want to choose based on your own choice of color and also preference. So right now I'll just have to do that just now. So once the dialog box appears right now, then we will have to now go and change our color for column, color for foundation, color for partition walls, and color for beams, and color for slab. So right now for the column area right now, I'll click on this place. I like to choose this particular one for my columns, or yeah, this one for my columns, and then I'll click on OK. And I like to choose my beams to be green color, to deep green actually. So I choose a deep green color for my beams and I'll say OK. I like to use my slab to be light blue, so my slab hashing should be light blue, or this, yeah, this is okay, and I'll click on OK. And I like my partition walls to have a dark gray color, and then the opacity to be at least 7, okay, 171 or 175, they're about 176. Okay, then I like my foundation to be um let us go down for foundation. Okay, my foundation, I like it to be still dark gray or deep gray. So foundation, this I like to have foundation to be not this, not foundation detail, foundation, yeah, foundation this. So I like this to be deep, this also, and the opacity also to have some sense of thickness. Okay, and then I'll now click on this place. Okay, automatically to change, once you can see there right now. So this slab is something else. I like to now, let me change the slab hash to blue. Let me change the hashing to this. Yeah, that's okay, and then click on this. Okay, so I like this to be this way. Okay, I like it this way. This is what I like. Okay, so you can now see how to change colors also to what you desire, what you want. So right now we will now have to now go and apply wall load. If you see what we call wall load, if I open this place right now and unback this place, you can see that on this beam, there is a slab here, and there's also a beam here. So on this beam right now, there is a block wall. This first floor block wall is sitting directly on the first floor beam, as you can see there. So we will have to impute this wall load on these beams. So that's what we are going to do right now. So right now I'll just go and turn off back this active reference drawing area, and then go and click on one of my beams right now. So click on this beam right now, right click and say edit beam wall load. So go and click here, edit beam wall load. Now on this beam wall load right now, we have done much video on how you can input these values. So this value right now is 3.47, and then on the height of this place, since the height of this place right now from this height, from this very point to this very point, is 3 meters. So I have to minus the depth of this beam, which is 300 millimeter for the, so right now 3 meter minus this right now gives me 2.7. So I'll just take 2.75 as my height of the, where the block wall we're going to occupy here, and then I'll choose my depth and my size of block wall to be 0.15 in this case. So I will now have to go here right now and then click at this place, okay. And once I click on OK right now, you can now see that very wall load right now is showing directly there. So by the time I click outside, I can now see that we now have our wall load here right now. So I can now copy. I'll click on this beam right now. I click and say copy beam wall load, since I've already done for one. So I'll just right click now and begin to select the beam which I want to which carries that wall load. So I'll just go and select all the beams that have that wall load, which is here also. And this go here, there is a wall load here, and there is a wall load all around this place, okay. And then here also, now there is no wall load here because this is like a lobby, and from this lobby that masters the client will be able to look out from here and look at what's happening at the dining area here. So I will now put a wall load on this beam, and then so since this place is like just 100 that to be here, and this beam alone can be able to carry that 100. Okay, so I'll click here again and then go here again right now and click here, and this internal partition beams, I'll also click on it, and while I'm holding my control key selecting this or so right now I'll now go here and right click and say paste copied beam wall load. So I can see here paste copied beam wall load. So by the time I paste it right now, all the beams will carry wall load, as you can see there. Okay, so all the beams which I've selected which I've already copied now has wall load. Okay, this one also has a wall load because this is a staircase region, so this place is not left open. So I'll click on this again and hold control key and click on this again. By click and say copy beam paste and copy the wall load and then click on OK. Now you can now see what we have just done right now. So you can see that if we now you can see what we have just done. You can see that right now. Like I said before, I let your culture be always to save. So once you do any changes, always try to save. So I'll just save right now what we have just done. So you can now see what we have done. Now we are trying to now enter the stage of the full analysis right now. So we are done with the modeling stage. We are now entering the full analysis and design stage. So hold on while we just do that right now. So we will now enter into the full building analysis stage right now. After that, right now, we'll now enter into interactive design. We have to check the all the members that were designed and see the kind of reinforcement that was used to design all the members. And then we will now enter into structural detailing, where we will use the Stonebridge company structural detailing template, which is customized to any kind of Prota version. So if you want that template, I'll say check on the link that goes that. I'll say check on the link down below and download it, so that when we enter the stage of detailing, you will not have issues with that. Okay, so right now you can now see what we have just done right now. Okay, you can now see all the wall load have now appeared. So let me just give this very shape here, this very shape right now, and this very side view, and then you can just take a look at this side view now. Take a look at this side view right now while I turn on back this external reference drawing, so that you can see the same side view that we have. So you can see the side view right now showing the cantilever, as you can see there. So if I also navigate right now to navigate this one back right now, if I navigate this back right now and show you this, you can now see what we have just gotten right. You can see that right now. So this is now our cantilever having a steel rail, small steel rail, and this is the column, and then this is the block walls for this first floor here, and that is what we have just inserted here right now. All the block wall all around, as you can see there. You can see that cantilever, and let me turn off back this so I can see it very clearly. So you can see the cantilever end, what we have just done, cantilever end here, and then you can see all the wall load, which is the first floor block wall and everything. So right now we have done all the all the modeling for this building right now, where this place becomes the upstairs, this place becomes the first floor, and this place becomes just the roof that will now reach at this very point. Okay, so right now we're now trying to enter the design stage of this building right now. So I'll save again right now. Then once it is done saving right now enter the design stage right now. Okay, so right now, since we are done saving right now, we are now trying to enter the design stage of this building since we have already done the full modeling right now. So I will now go back to plan view just now, and on the plan view right now, I will now go here and then click back on this place, or we can still be on our 3D view. If you want to be on 3D view, it's still the same thing. So I will now go here and then click on this place called analysis tab. On this place, I'll now click on building analysis, and then on dialog box appearing, I'll now click on this place loading combination first. Or most times I like to click on this place. Okay, let us click on edit material. So I have to go and change the material, which is the concrete grade and the steel grade. So I'll click on this place right now and choose my concrete grade to be 25 and 20, and then click on this place, say apply to all. Most people used to use this, which is the okay, but by using their concrete it to be 20, and me, I like to use this also and any of them, but for this case I want to use this. I will now click on what they call okay, and then go to this place right now and click on grade of steel. On this grade of steel also, I always advise you to use not the highest grade of steel. Also always use the lowest, because most times the company manufacturing the steel might not be able to meet up to the highest strength of steel. So I always like to use 410 for my grade of steel, and then click on apply to all members, and then click on OK. Now I want to now start choosing my column reinforcement, or my size of reinforcement for the members. So for the columns right now, I'll click on this place and then just click on this place and again, and then click at choose my minimum reinforcement for column to be diameter 16, and that's all, and I'll click on OK. I don't want to choose a maximum because this is just a small building. So I'll go again on the concrete beam. Now concrete wall, this is not a partition wall. This wall you're seeing here is not a partition wall. So this wall is like a reinforced wall for a lift, or the wall that you can see around the bridge, abutment or embankment. So right now we don't use this. Since this wall is not found on this building, so there's no need for you to choose anything here. So I'll just move directly right now. I'll move to beam and then click on the beam one, select first and unselect again, and then choose my maximum size of reinforcement for beam. I'll choose diameter 16 and diameter 12 also, and then click on OK. Okay, so I'll choose 12 and 16 as minimum. On this reinforcement also for the column, I'll also choose minimum to be 12, because on this area, which is just to carry the parapet, here will be diameter 12. Why here that is carrying the first floor, which is the pen floor, we carry diameter 16. Okay, I'll now click on OK, and then go to my slab. I'll just unselect and select again, and then choose just diameter 12 for my reinforcement of a slab. And then go to this place right now and choose my links. For my links right now, I'll select and unselect again, and I'll choose my link to diameter 10 and then OK. And I can choose diameter 10 and minimum diameter 8. So I'll go here and choose minimum diameter 8 and 10 maximum, and I'll click on OK, and then I'll click on for the foundation right now. I'll go the same thing here, which I've already done. Unselect here and unselect again. Foundation, I'll choose diameter 12 as my foundation reinforcement, and then for the links, okay, it's already there, and I'll click OK and then click OK finally. And on this place right now, to now load, then apply the that design formula, and I click on this place called loading combination, and then on this place right now I'll click on this place called loading generator, and then I'll wait for it to generate all the loads. Now since we don't have any wind load on this building, there's no need going for horizontal loading combination, so I'll just click on this place vertical and then click on OK. Automatically right now it will show all the load that you can see there right now, the combination, which is G plus Q and G plus Q um, times B1. So all this right now will be used to now design for the structure. So I'll now click on OK, and then with this right now, we have done, I'll now go here right now and click on analysis, and then I'll perform what they call building model check, so that if you're having any slab or beam overlapping each other, or column overlapping, you will see all the errors here. So I'll click on this place now and then click on start while we wait for it to come up with any error. If there's no error, then we now move on back to straight away to the video. Now you can see that there is no error. Number of errors is 0. So with this right now, our model is very okay. So we now click on close. Now if you have issues in your model, in my next video I will show you if you have issues when you don't have when you see any place there, when that error is not 0, I'll show you what to do. So right now we'll now go and click on this place, building analysis right now, and I'll click on this place just now. And on this place right now, they are asking us if we are going to, if we want to design or just to analyze. So I want to perform the full design also. So I'll say design column and design beam. But since we don't have any steel structure, which is here, which is like steel truss and all that, we don't have it here. So I will not check this. So I will now click on this place called analysis and design. So while we wait for it to now perform the full structural building analysis and design right now, so let us just hold on for it to finish up. So it's just trying to run it now internally right now. First of all, it's trying to save. You can see this thing called here saving. You can see here saving the project. Please wait. So it first of all tend to save all the material this that we have changed and all the concrete grade that we have changed before it will now begin to now perform the analysis and design. So in the next couple of seconds, it will begin the full analysis and design, which you now begin to see this place now will now begin to locate. So right now it can now begin to perform the full analysis and design. So you can now see what it's trying to do right now. Okay, so right now you can see that how we have modeled this building from scratch to this very end. In our next video, I'll be showing you the detailing of slab, and also we will transfer all the design detail to AutoCAD, and right there in our AutoCAD, we will use the Stonebridge company structural detailing template to perform the full structural detailing for this structure. So if you don't have that Stonebridge company template, I would say check on the link down below and download that template. It will help you a lot because it will reduce your workload on your structural detailing to at least 80%, which is very compatible with Protastructure and any kind of version. Okay, so right now we will just wait for it to perform the beam design. The column design has already been concluded, so let's just wait for it to perform the full beam design, which we are trying to wait right now. In a couple of some seconds, this will be all over, and then we will have to now check our model if everything's okay. Okay, so right now we will now click on this place, okay, and just say okay, and then click on this place and say close. Now it took us just 1 minute 12 seconds to perform all the design details. Okay, so we can now go here right now and click on close. Okay, so let's wait for here to turn up, and then we'll click on close. Okay, so you can now see how we have performed the full structural modeling, analysis and design right here in Protastructure. Okay, so if you have any question, I would say you should drop your question down below the comment section, and we will reply you. We have always been replying all our subscribers on all their questions and helping them both in our comment section and also using our WhatsApp platform to help them out. Okay, so right now you can now see that we have done the analysis and design, so we can now click on this place called OK. So once this is turned on right now, we can click on OK. So just hold on for it to transfer to show us the next phase. So we can now click on OK right now. So this is now the next phase. I don't like to choose anything here. I'll just go back. This is trying to show you the like all the result stage of what we have done, which is called analytical model. So I'll just go back to my 3D model view right now, and then you can see what we have done. So right now there is what they call design check. So when you have performed all your design, and then you will have to go and check your design if to see the members which has failed and the members which has passed. So we are trying to now enter into interactive design. So but before then, we will have to check the visual interrogation first. Okay, so right now we will not check that right now. So once you're done with your design right now, the next thing to do right now is to check visual interrogation. So to do that right now, we will now click on this place, visual interrogation, this icon here, visual interrogation, and then it will show you the detail box right now. You just go down to this place and then check for your design status. So check on this place right now and click on OK. So with this right now, you will see if your members passed, you will see that they have passed, and if there's any failure, you see that they have failed. Now you can see that all our beams right now are showing green, but our columns are showing red. So let us check why it is showing red right now. So I'll click on one of the columns right now, right click and say column session design. You can see there session design. So I'll check on that right now to see why it is showing like that. So I'll click on that right now and then try to run back interactive design, and then you can see that it's showing 12 6y 6 diameter 12. You can see that 6 normal diameter 12. So click on OK and then say OK. So right now I think what happened on that place was that because I didn't choose let us hold on, I didn't choose a maximum and minimum reinforcement for column. So let me go and choose a, let me go here right now back to our analysis loading area here, because I don't want to change this manually because it will take my time. So I'll just go back here right now on my analysis and design and click on this place right now, and then click on this analysis tab and back to this place right now. On this, sorry, first I'll go back to this place and choose material for column maximum. I'll choose my maximum to be 20, but I know that I'm not going to use 20, but I'll just choose 20 and then go OK and then OK, and then I'll go back to this place right now, analysis, and then click on this place. Now on this column area here, I'll select it through again and say select bar if any failure, and then click on begin analysis, and then wait for it to make that changes again and for it to now begin again. Okay, so let's just hold on right now for that stage to continue again. So right now you can now see that once you're done your first design or your design and you check on this place called interactive, this place called visual interrogation, and then you see any of your members showing red, that red means that I can see that red means that that member is failing, and if you see green, it means that that member has passed. So you can see that all our beams are showing green, which means that all our beams are okay. Now the columns we are showing red doesn't really mean that it has failed, but just that because we didn't check that maximum and minimum reinforcement, and we didn't give it instruction that once any of the members failed, it should choose the higher reinforcement. So that's why you saw that all our members for the columns failed. But right now that we have made that option right now, you will see that once this is done right now, you see that all our members, both the column and beams, will be showing green. Although if any column again shows red, which is failure, then we will not perform what they call interactive design on that particular column. Okay, so right now let's just hold on for it to finish up right now. Okay, so let's just hold on right now while we wait for it to just round up. Okay, now it's trying to perform the beam, the beam design right now. It's trying to perform, no, sorry, the column design. Now it's trying to enter the beam design stage right now. Okay, the column design right now is already done. You can see 20 of 28. Now once it's done with column, it now enter beam immediately. So it's trying to perform the beam design right now, which I've already given. Now you can now see that all our columns are fast because we gave that instruction that once any of the members failed, it should choose a higher reinforcement for that. Okay, the same thing will happen to the beam. All the beams also will also pass. So it's always good to make that kind of option in most of the designs. Okay, so right now you can now see that we just say okay and then click on this place close, and then you will see that all our members are now showing green. Okay, so let's just hold on for that to finish up right now, and then it's trying to show us, just say okay and then click at this place and then click close, and let's hold on for it to just transfer us to the other model, which we are not going to use. We will just close it up and then just click on this right now, close, and then go here and go back to our 3D model view. Now you can now see that we all our this have now passed, as you can see it here. All our members has now passed, as you can see it here. You can see that all our beams are showing green and columns are showing green. Now there is what they call interactive design. Now even if your beams even if all your members are showing green, it is advisable to check all the members one after the other to see the kind of reinforcement that was used to design that particular member. So like if you check on this beam right now, if we check on this beam right now, I click and say section design, and you will see, let us check the kind of reinforcement that the software used to design for this beam, because most times it can use a higher value of reinforcement, which is like y diameter 50 or 30. So you can now see that it is using 12 here and it's using 16 here, which is not right, which is not okay at all. So it is your right now as a civil engineer or as a structural engineer to now begin to change the type of to now begin to choose the type of steel that you want to use. So I want to use on this place, I want to use diameter 16, which is two numbers, and I'll put here also two numbers diameter 16, and I'll go here right now and remove this option. Okay, increase this right now, then go here and lap this reinforcement into just put it to lap so that it can lap inside this place, and then go here again and lap this reinforcement also, lap into the column to lap also, and then go here and remove this reinforcement just now, remove this reinforcement now, make it 0, and then leave this as support, or I'll just remove this right now and go here and increase this to 3. It's trying to fail, so I'll just add a support bar here, to make it 2, and then go here and make it layer 2, and then decrease this back to 3 to 2, sorry, and then go here, and this is already okay, the area of steel here is okay, so this 2 here is okay, and make this one is also okay. Now try to lap this into the column also, or to the nearest support, which is already here, column and column, and then I will now have to, here is showing me 4, so I'll just reduce here and take it to be 4 at once along here. Okay, 3 is already okay, so I'll make it also to be 3 too, make it to be 3 so that it will not be confusion during construction. Okay, so right now we have 3 number of reinforcement up and bottom, and we have 2 top. Now once this value, okay, now you can see that also here is showing us less than 18. Always good to have this value more than 20 or 20 minimum. So the reason why this place is showing me error is showing me less than 18 right now, sorry, less than 20, because once this value is less than 20, you have to make it to be up to at least 20 and not below 20. So right now, because of that, it's showing me because our beam width is 150. So right now I'll have to make this 2 and add 2 at the bottom. I would have added one, but one will not be okay, so I'll add 2, 12, and here 3 is already okay at this place. So right now, what we have right now, we can make it 216 at once, because I don't want disturbance or any kind of slight confusion aside. So we now have 2 top here and 2 numbers again as a support for the reinforcement. So we'll now go here and click on OK. Now you can see that we have checked this beam right now. So I'll just go here and click on my story on my plan view right now to be able to see the beam clearly in a plan view. So we have already checked this. This is just the beam that we have checked just now. So let me just show you back that we have already checked this beam just now, which you saw here right now. So it's just say okay. So always good to check your beam after your design. So I'll check each of the beams, and then we'll also check the columns also. So check the beam this beam right now. So I'll check all the horizontal ones. So I don't like the way that this is. I can now you can now see what is done here right now. They are giving you delta 16 up and bottom as under 12, which is not okay at all. So because this one now right now we need to cause a question aside, how will your top bar become 16 and your bottom bar, which carries the load, becomes 12? So it's not really nice. So right now I'll have to make it 16 also. Now you can now see why it is good to check your beams even after you have done your design and then the software shows it that it's okay. So always check your beams. I'll lap this reinforcement inside the column, and lap this also inside the nearest support, which or the column or beam. Sorry, I'll lap it inside the nearest support here, and then remove this number of bar here. Remove this bar here, and then try to remove this now to see if that will be okay. If once it's okay, it's not okay, so I have to put that bar back and then make it here to be layer 2. Okay, so right now it's not okay, so I'll just go here right now and then okay, that's okay and okay too. I'll go here right now and check this okay and this okay. I can make here to be 3 because if I check the diagram here, let me see the diagram. I think here tends to have a higher top bar, a higher top moment than the bottom moment. Let me check the diagram right now and then see what's happening there. So the diagram of this place will tend to be higher than the bottom reinforcement moment. Okay, let us see if that's okay. You can see that we have a higher value of top. We can see there. So this for shear force. And I can now see that we have a higher value of our top moment here. You can see that right now. So because of that right now, I'll go ahead and make my here to be 3. And now because of 3 right now, it's trying to lessen the space of where the concrete is going to pass through the reinforcement. So I'll reduce here right now to be 2. Now during the structural detailing right now, I'll make these 2 support reinforcement here to be able to pass through this span. So this is also okay, and I'll click on OK, because most times if you cannot perform it very well during the design, and with your experience you can now perform it, you can now show it very well on your detailing. Okay, so right now we'll just go and click on OK here, and then make this to be diameter 16, not 12, and then lap this to the support, and also lap this also, and then I'll now go here, this okay, and reduce this to 2. Let me see, 2 is okay. So with this right now, this is okay, this is okay. Now this tends to have 5, as you can see here. So I'll just go here and then increase this to 3. Now on this place right now, since it is almost close to 20, what happens is that when they are casting this beam during construction, they will have to apply pressure, or they will have to use a poker machine to be able to so that the concrete can be able to pass through these 2 reinforcement, the spacing of reinforcement. So it is also okay. So I'll now click on OK, and then I will also check. Now I'm done checking the horizontal one right now. I'll now go and check this vertical one. Let me start from here, vertical one. I'll click on this place and say section. Now you can see how we are checking our beams one after the other. So this is what you're meant to do to check your beams even after design. So when I click on what? Okay, that's okay, and do the same thing here. I click here and say properties, section design, and click on this, increase that, and this is okay, 2 up, 2 down, that's okay, and do this also. And then I'll check this also right now. I click here and then click on section design and check the reinforcement there, decrease to 16 and also to 16, and then okay. And then I will now go here and check this particular one right now. Right click here and then say section design, and then I'll now go here and then click on. I'll click on checking all this right now. Now I'll check this place. All the places that have the depth of beam of 450 will be diameter 16, and the rest place that just have the depth of 300 will be diameter 12, because that place does not carry slab. It's just carrying the roof, and this diameter 12 can be able to carry the roof load or the parapet load of that area. So I'll just go here and increase that to 16. This place also 16, and then I'll go here right now. From this place now becomes where the parapet is, so this is okay. So I'll click on OK, and then I'll also go here and do the same thing to check this one also. I click here and say section design, and then I will now go again here. Once the logos shows, I will do the same thing here, where we have this 450 depth of beam becomes okay, this 16 right now, while all these places that have 300 depth of beam becomes 12, because this place is not carrying any slab, only this place that is carrying slab. So I'll click on OK, and then um we will have to check this also. I'll show you the reason why I see that place is not carrying slab. I'll show you this place right now. So this place right now does not have any slab, so all this place becomes 12. That's okay. Now if we check on our 3D view right now, let me just show you how why I see that place not carrying slab. You can see how the building is. This place is the place carrying slab. If I go out from this view right now, from this particular view, okay, let me just be there first. So you can see that this place is carrying slab, while this place is not carrying slab. So that's how it is. Okay, so right now we will now go again at the very point edge right now to now go back to our plan view again right now, and then begin to now once we are done checking our first floor area, right, first floor beam right now. It's also good to check also your roof beam, also check the roof beam also to see the kind of reinforcement that the building, that the software used to pass the the roof section area. So just check this immediately since they are just small. So check this also. I always advise my subscribers that you should spend time to check all your steels, all your reinforcement that the software used to pass your building members or your structural members for you. Else, if you just go ahead and you didn't spend time and go ahead and go and export all your details out, you are going to be having issues for either oversize of reinforcement, or your the kind of connections you'll be having will not be okay. So since this is the roof right now, I'll use just diameter 12 for all the size of the reinforcement for the beam for the roof. So I'll just go here and say okay. So always spend time to check all these one after the other so that you can be confident to tell anyone aside, no, use that place as 2y16 or two number of diameter 16 or 12 or any kind of value, because you have already done it separately again. You have checked it as a good structural engineer. You have checked it one after the other again. So always good to check your beams one after the other, because it is only that you have authority. If you don't check all your beams, that means what you don't have authority over what you have done, because it is just a software that gave you all your reinforcement. And most of you begin to complain that you don't like the way that Protastructure used to detail your beams for you. That's because you didn't do all these things. Now, by the time you have done all these things right now, and then transfer your bin details to AutoCAD, you will see how all your bins will be detailed perfectly, because the Protastructure with this software we like also understand that you have done your own manual checking, and you have done all the things that are meant to be done. Okay, so right now you can now see that everything is okay. This is the last one. This is the last one. So check on this right now, and then this okay also. Since this is the roof, so I would use them to 12. But if it's for a floor beams, I always advise you use a minimum depth minimum size of reinforcement to be 16 and depth of beam to be 450. Okay, so this is okay right now. So we have done all our checking for the beams right now. Now for the columns right now, we will now go and check for the columns. For the column area right now, I'll just go here. I'll just go this place right now, right click here and say column, this place here. Choose this first one here. So I'll choose that one right now to see my column steel bars. Okay, for the column right now, you can see that the column it uses diameter um, 12, which is okay, adequate for the building, because the building is not that heavy and it's just a paint floor, so it is okay. Although during my detailing, I can choose to use this very area which has the paint floor. I can choose to use this very area which has the paint floor. Let me just show you. I can choose to use this place which has a paint floor, all the columns that are carrying the paint floor to be diameter 16 downward and upward diameter 12 of reinforcement. Okay, so right now you can see how we have done that right now. So we will now go back right now to our model. Go out from this model view right now and go back to our model view here right now. So we will now begin the foundation design for this right now. So right now, once you're done checking all your beams and columns, as you can see what you have done, the next thing to do right now is to now begin your foundation design. So I will perform the foundation design in my next video, which will be the part 3 of this video. So I will now perform the foundation design, which we are going to use a part foundation for this design. So watch out for the next, because in my next video I'll perform the foundation design, and then we will also go ahead again to now begin to transfer all our members, all our detail members to AutoCAD. Here we will now perform the full structural detailing using the Stonebridge company structural detailing templates. Okay, so right now we have come to the end of this video. If you have any comment, like I said before, drop your comment down on this link, on this video link below, and also please try to like this video and also share this video if you want us to grow more on this platform YouTube. Okay, so thank you so much and God bless you, and we love you all.